your camera direction. Your face
Not
is
visible.
not visible. Now it is okay.
Okay.
Now it is okay. So everything is ready?
Yeah. Nice.
Okay. Unfortunately, in our office, there is no power. So I'm sitting in my home and Priyanka is also here.
So it has to be announced.
We will
So
announce it.
people
Still time is there. It's still 6
to wait.
minutes there. Just to once it becomes 4 o'clock, I will announce. Okay.
Yeah. We can wait another 10 minutes. When
Then we'll announce. Yeah. Topic. Low carbon aluminium sustainable metal. Low carbon aluminium sustainable metal. The future. Very good. I will announce. Even.
we may start at 4:10, depending on people.
No, exactly at 4. No 4:10. Nothing. We have to start in time. Oh, Taku Harato is there. Muhammad Nazar is there. And Info Sanchiti is there. So only Muhammad Nazar and Taku Harato.
Yeah, thank you very much for sending me the
Hello,
address.
Taku. How are
Hi,
you?
how are you? Fine, thank you.
Very good.
Yeah.
Very good. You are interested in the smelter paper also?
Yeah, I'm very interested in alumina and the aluminum industry. So I still studying many things.
Okay, very good.
Thank you.
So we will
Yeah,
wait
thank
for
you.
another 4-5 minutes and we will start. Finally, we
Yeah.
are with us.
Thank you.
Oh, 11 persons are there already. सबका म्यूट कर देना. हाँ, चाहिए. Everything is good. क्या? हाँ, no, है इंटरनेट है. Claro. तीन मिनट में स्टार्ट करेंगे.
Power has come?
Yeah, no, we are sitting in my residence. So,
Oh, in
George, you
your
are
res-
also here. Very good, George.
In,
Okay.
in your office, it is there, power?
Our power is there. Just to aware. Don't worry. Okay, start. Shall we start?
दासो गुड आफ्टरनून
हाँ, good afternoon, good afternoon. सुनी देखी खुशी लगला.
Oh, Mr. Kawande is also there.
Yeah.
oh nice I am in the train but still I attending
I had told Kawan.
Okay. Good morning, good afternoon, good evening, ladies and gentlemen. So today we are having this is a fourth lecture series of IBAAS JNARDDC technical lecture series of 2022. And the presentation will be made by Mr. Satyanarayan Das, retired DGM NALCO Smelter, on low carbon aluminium, sustainable metal of the future. So this is a pre-recorded presentation, and we welcome Mr. Satyanarayan Das, and the presentation will start in another 2 minutes. Kindly bear with us, and then it will be followed by 30 minutes questions and answers. So request our team to start the presentation.
Welcome to low carbon aluminium, sustainable metal of the future.
Sound.
The scheme of presentation is context. Carbon reduction is the main concern across the aluminium producer globally, with a focus to reduce carbon footprint to combat climate change crisis. Next, aluminium industry emissions are both direct and indirect emissions. I will discuss pathways to decarbonize operations to produce low carbon aluminium. Next, I will cover low carbon aluminium production under different brands by major producers world over. Next is recycling aluminium. Aluminium is infinitely recyclable with energy input 5% of that required for primary aluminium production. Next is why green aluminium is more sustainable compared to other products. It is because certain unique properties like high strength to weight ratio, long life, and value it offers over cost are the foremost considerations. Finally, the way ahead for aluminium smelters to go green. Climate change is the biggest challenge of this century, causing environment degradation. The root cause is global warming due to emission of greenhouse gases. To fulfill above obligations, right from Kyoto Protocol, Paris Agreement 2015, International Panel on Climate Change, IPCC, and ending with 26th United Nations Global Climate Change Conference, known as Conference of Parties 26, have been undertaken. Paris Agreement 2015 targeted global warming below 2 degrees centigrade by end of century, above pre-industrial level, that is 1850 to 1900. Conference of Parties 26 held at Glasgow last year targeted to achieve global net zero emissions by 2050. India committed to achieve it by 2070. India also committed to achieve a 450 gigawatt capacity per annum of renewable energy and 40% renewable energy generation. It also targeted to achieve average rise in temperature limited to 1.5 degrees. Net zero emission is reducing greenhouse gas emission across all sectors of economy. Net zero level means global warming will stabilize at this level. International Panel on Climate Change 2022 assessment report predicts global warming to exceed 1.5 degrees this century without deep reductions in greenhouse gas emissions. The impacts will be severe in the form of extreme weather events, sea level rise, flash floods, cyclones, etc. Aluminium industry contributes 2% of global greenhouse gas emissions. Greenhouse gas emissions are categorized as carbon dioxide equivalent. Primary aluminium consumes 4% of electricity. More than 60% emissions in aluminium production are indirect emissions attributed to electricity consumption. Best way of presenting greenhouse gas emission of production process is to use life cycle methodology, that is from mine to end product. Across the aluminium value chain, right from bauxite mining to aluminium end of use. There are several sources of emission in bauxite mining, bauxite tailing, alumina refining, red mud, power generation, CO2, CO, hydrogen fluoride, perfluorocarbon emission. In anode manufacturing, carbon dioxide, sulfur dioxide, aluminium smelting, PFC emissions, and carbon dioxide, hydrogen fluoride, and sulfur dioxide. Aluminium end of life ends up in landfilling. Emissions in primary aluminum productions are both direct emissions and indirect emissions. Direct emissions is process emission, that is carbon dioxide, carbon monoxide, hydrogen fluoride, perfluorocarbon, sulfur dioxide. Indirect emission is coal-fired power generation. 80% carbon equivalent emissions across aluminum value chain is smelting operation. And the major goal is reducing carbon footprint. Aluminum production is both energy and carbon intensive. World specific energy consumption is in the range 12,000 to 14,000 kilowatt-hour per ton aluminum. In India, it is 13,200 to 14,000 kilowatt-hour per ton of aluminum. Global primary aluminum industry emissions is explained in this figure. 2.6% approximately is the emission from aluminum industry globally. And the balance 97.4% is the rest of the world aluminum industry. 70% of the emissions are accounted by Chinese aluminum industry, whereas 30% is the rest of the world. 62% of the emission is from thermal power plant, where coal is used for firing. 13% is Scope 1 emission, that is emissions from the process, and 25% is cradle to gate, that is from bauxite mining to ingot production stage. There are different sources of emissions across aluminum value chain: process, electricity, fossil fuel, transport, auxiliary, PFCs, and the total emissions is approximately 12 tons. Power mix of aluminum versus total power mix. Coal accounts for more than 53% of power in the power mix. Next being hydropower, followed by gas and renewables. Total power consumption globally shows the bulk of the power consumption is from coal firing thermal power plant, followed by natural gas, hydro power. Global power mix and primary aluminum production. Region-wise, China accounts for major power generation by coal firing, followed by hydropower. In Europe, including Russia, it is 90% hydropower. In Gulf Cooperation Council, it is 98% of the power is natural gas. In Asia Pacific, excluding China and including India, maximum power generation is by coal-firing thermal power plant. In North America, hydropower accounts for major power production. The challenges to decarbonization is the fossil fuel release, like carbon dioxide and other greenhouse gas emissions. Thermal energy is fuel for heating in anode production and casting, while steam is used in alumina production. Countries like China and India are heavily dependent on thermal power, while Gulf countries are dependent on natural gas. The tendency worldwide is to operate high-amperage cells in the range 400 to 600 kV for higher productivity. Carbon footprint increases by requirement of more coal-fired power. The emission levels in thermal power is in the range of 16 to 18 tons carbon dioxide equivalent per ton aluminium. Hydropower is 2 to 4 tons carbon dioxide per ton aluminium, and gas power plants 5 to 8 tons carbon dioxide equivalent per ton aluminium. The total emissions of 3.5 ton carbon dioxide equivalent is possible for cells with best available technology in all parts of aluminum production steps, including renewable production. Coming to pathways to decarbonization, the process. The best option is to improve energy efficiency of operations by adopting best practices and making incremental improvement in reducing energy consumption. Benchmark specific energy consumption APXC is 12.9 kilowatt hour per kg aluminium against 12 to 14 kilowatt hour per kg aluminium at world level. Reduce net carbon consumption by improving anode quality, adopting best practices, and adopting good covering. This corresponds to 1.4 kg carbon dioxide equivalent per ton aluminium. Increase share of low emission energy sources like renewable energy. In Europe, the best option is to go for a mix of hydro, nuclear, and wind. Dunker Aluminium Smelter in France uses 100% nuclear power, whereas Lochaber and United Kingdom uses mostly hydropower. In India, due to the dependence of industries heavily on coal, we have to phase down the use of coal-fired power in thermal power plants by a renewable mix of thermal, solar, wind, nuclear, if possible. Natural gas may be explored for substituting HFO, LDO in cast house and carbon plant. This picture shows energy consumption versus cell voltage for advanced aluminum cell technologies. It varies from approximately 12 kilowatt per kg of aluminum using APXC 500 kiloampere technology of Rio Tinto to 12,500 kilowatt hour ton aluminum of GAMI 350 kiloampere and SY 600 kiloampere technology of China, which gives energy specific consumption of 12.14 kilowatt hour per kg of aluminum. HAL4E technology Ultra of hydro aluminum in Norway has given consistent performance in the range 11.6 to 11.7 kilowatt hour per kg of aluminum. This is by far the best specific energy consumption world over, which is being tried for last 10 years on pilot scale. They have a vision to go down to 10 kilowatt hour per kg aluminum. Emissions from byproducts are red mud, spent pot lining dross. Red mud is through leakage, spent pot line chloride and cyanides are hazardous materials. 50% of it is landfill. Dross, which is 5% of the production, generates salt slag. Rio Tinto Hindalco uses red mud in cement industry. Alba recycles SPL commercially through zero waste approach. As per media report, Vedanta Aluminium commercially recovers aluminum from dross through its startup, Runaya Refining, using patented technology of Messrs. Ta International. Inert anode is a revolutionary technology of future, which has been tried and found successful in pilot scale. This will be alternative to consumable anode in smelting. It emits oxygen in place of carbon dioxide. Best option is to reduce direct emissions associated with anode carbon consumption around 15% with the use of renewable energy. However, energy requirement is higher. The energy requirement is 9.2 kilowatt hour per kg aluminum, which is the theoretical minimum energy required in this compared to the minimum theoretical electrical energy of 6.4 kilowatt hour per kg aluminum in conventional Hall-Héroult process. However, inert anode process can be retrofitted in existing cells along with inert cathode, that is drain cathode, which permits low acidity with the limitation of heat balance and magnetohydrodynamics in cell operation. Technology is not yet commercialized, though successful in pilot scale in several locations. Costs of inert anodes are not known, but the high energy cost is believed to be offset by the elimination of carbon anode plant. Elysis, a joint venture between Alcoa, Rio Tinto, have been producing inert anodes to produce low carbon aluminium. 2 demonstration pots at Alma Smelter. $450 kiloampere is in process. They are hopeful to commercialize it by 2024. Rasal in Russia is successful in pilot batch low carbon production, which ensures very negligible greenhouse gas emissions. Arctus Aluminium R&D along with Innovation Center Iceland has produced high purity 99.9% aluminium in test cells. Carbon capture and storage technology is the capture of direct carbon dioxide emissions from industrial processes that are then transported, used as an input to create another product, or stored permanently underground. It is viable in sectors where off-gas concentration is greater than 4%, and so promising solutions that have access to cheap fossil fuels, have no recourse to affordable renewables, and have access to affordable carbon transportation and storage facilities. However, this technology is highly expensive for gas streams with low carbon dioxide concentrations, like aluminum smelter. It demands large amount of energy. It is potentially attractive for captive power plants with carbon dioxide concentration, 14% approximately. Trials are going on in Europe, USA, China. China has around 44 pilot plants in process. Alvance in Scotland is framing a pilot to launch by 2024 to capture emissions from smelting process. Green hydrogen by far is possibly going to be the future fuel source. This is shift from fossil fuel to renewable energy through green hydrogen. Uses renewable energy powered electrolysis to produce hydrogen from water. Green hydrogen use is limited at a commercial scale, but electrolyzers themselves are an established technology. Indian Oil Corporation Panipat Oil Refinery pilot scale trial has been successful, and they reported it is cost effective also. Government of India National Green Hydrogen Mission has ambitious plan to promote use of green hydrogen through R&D efforts. Recycling of aluminium provides opportunities, as aluminium supports more circular and sustainable economy. World aluminium recycling efficiency is approximately 76%, while in India it is approximately 25%. Aluminium is infinitely recyclable, with energy input required for recycling is about 5% that for primary aluminium. Recycling reduces greenhouse gas emissions by 90% compared to primary aluminium. 1% increase in aluminium recycling rate can reduce overall product footprint by 80 kg of carbon dioxide equivalent per ton of aluminium. Ministry of Mines Non-Ferrous Metal Scrap Recycling Regulation 2020 ensures regulating unorganized sector by discouraging import of scrap aluminium. Challenges Indian scenario. In India, scrap recycling is confined to unorganized sector. It has high level of contaminants, including toxic compounds, steel, plastics, and other debris in purchased scrap. The challenge lies in shredding, sorting, and further refinement of metal to achieve acceptable purity levels, particularly in some premium alloys. There is need for standardization of melting practices, which we are lacking. Low carbon aluminium is green aluminium produced using 100% renewable energy. Consumers are demanding sustainable low carbon aluminium which protect environment, conserve natural resources, and support circular economy. Carbon footprint of low carbon aluminium is fixed at 4 ton carbon dioxide equivalent per ton aluminium, considering direct and indirect emissions. The Aluminium Stewardship Initiative is a sustainable international standard which limits 8 ton carbon dioxide equivalent per ton of aluminium, covering Scope 1 and Scope 2 emissions. London Metal Exchange is the trading platform for end users and buyers, which carries premium. Product footprint boundary is defined by International Aluminium Institute as cradle to up to and including ingot casting. Basically, there are 3 levels of emission. Level 1 emissions are from aluminum electrolysis, aluminum ingot casting, anode from paste from anode plant, generating electricity, heat consumed in these processes. Level 2, in addition to level 1 emissions, direct emissions from bauxite mining and alumina refining, associated emissions from electricity and heat consumption and fuel combustion at these 2 production unit processes. Level 3 emission is a complete cradle to gate carbon footprint of aluminum ingot. This includes greenhouse gas emissions from bauxite mining, alumina production, carbon anode production, aluminum electrolysis and ingot casting processes, raw materials, transport, electricity and heat generation, and aluminum dross processing. Coming to low carbon aluminum products produced under different brands. Hydro aluminium in Norway produces under brand Hydro Circle 75R and Hydro redox of through hydropower. It has a carbon footprint 4 ton carbon dioxide equivalent per ton aluminium. The circle uses minimum 75% recycled post-consumer scrap and is certified with a carbon footprint below 2.3 ton carbon dioxide equivalent per ton aluminium. Circle 100 are in recycling plant in Luxembourg. Uses 100% post-consumer scrap to meet needed composition, has a carbon footprint greater than 0.5 to 1 kg carbon dioxide equivalent per kg aluminium through the value chain. Rio Tinto under brand Renew Ale uses hydropower which has a carbon footprint threshold less than equal to 4 ton carbon dioxide equivalent per ton aluminium. Start a natural nutrition level using blockchain technology. Naval provides key information about the site where aluminium was responsible produced, covering several criteria. It would help customers meet demand from consumers for transparency. Alcoa produces under brand Ecolam using hydropower. It has a footprint threshold greater than equal to 4 ton carbon dioxide equivalent per ton aluminium. The product comes with certification confirming sustainability metrics of the product line. It has third-party verification of environmental product declaration. UC Rasal Russia produces under brand Allow. The carbon footprint threshold is 4 ton carbon dioxide equivalent per ton aluminium, which includes direct and indirect emissions. It is certified by British Standard Institution. Pilot study using inert anode in electrolytic cell is expected to reduce significantly carbon footprint. Vedanta Aluminium under brand Restore is the first plant to produce commercially green aluminium using renewable energy in partnership with Runaya Refining, a startup, for processing dross at Vedanta plant Jharsuguda. The carbon footprint threshold is below 4 ton carbon dioxide equivalent per ton aluminium. Restra Ultra Bond aims to achieve near zero carbon footprint. Emeritus Global Aluminium produces under brand Celestial, which is the first commercialized low carbon aluminium using solar power in association with Dubai Electricity and Water Authority. The carbon footprint threshold is not available. EGA has very recently announced to build a 150,000 ton per year aluminium recycling plant and intends to market recycled aluminium under brand name Etern AL. Harbor Aluminium USA produces under brand USMWT 1020 green aluminium with spot premium. It has a carbon footprint threshold less than equal to 4.5 carbon dioxide equivalent per ton aluminium. The product is specified as spot physical 99.7% high grade aluminium, covering scope 1 and 2 emissions. Worldwide, aluminium consumption pattern shows Transport accounts for 27% approximately aluminum consumption, followed by 22% building and construction. Whereas in India, it is comparatively low in transport, around 15%, and building sector, it is 5%. Let us now see how aluminum compares with steel. The analysis reveals aluminum emits 11.7 tons carbon dioxide equivalent per ton aluminum compared to 2.5 tons carbon dioxide equivalent per ton aluminum in steel. Aluminum production consumes 8 times more energy per kg than steel production. Life cycle cost analysis reveals 22 carbon dioxide emissions saved in life cycle as compared to steel. High strength to weight ratio makes aluminum sustainable for application in aerospace and in light combat aircraft. Lightweight of aluminum, 1/3 of steel, makes it ideal for automotives for fuel saving. Melting point of aluminum being low compared to steel results in high remelting cost. Low carbon aluminum, sustainable metal of the future. Due to lightweight, high strength to weight ratio, excellent corrosion resistance, excellent thermal conductivity, as well as has recyclability at the end of life, with minimal energy without loss of quality. Building and construction sector is responsible for over 1/3 of global energy usage. Aluminum strength makes it the first choice for structural frameworks, while its reflectivity makes building more energy efficient. Green building is a new concept with less carbon impact and more energy saving, and is popular across the world. When used as base metal in construction, aluminum structures weigh about 35 to 65% less than traditional metals like steel, while providing equivalent strength. World average consumption in building construction is 24% approximately, as compared to approximately 11% in India, mainly due to high cost. But in India and in developing countries, its use will increase in coming years as per capita income increases. Aluminum doors and windows gaining increasing prominence in architecture for benefits of structure, sustainability, and aesthetics. In extreme weather conditions like India, it is preferred material for fenestration, opening in window arrangement, since it is non-reactive, non-corrosive, and recyclable. Its intricate shape in interiors of building is useful by using extruded doors and windows which allow for maximum airflow. The design of facade minimized wind load of Shanghai Tower, China, reducing the amount of material needed for construction due to low weight of facade. Aluminum composite panel in green building contribute to sustainability due to inherent properties of anti-corrosion of aluminum. Aluminum with small amount of zinc is replacing galvanized roofing sheet, keeping corrosion resistance intact along with weight reduction. Substantial saving in energy usage is achieved using aluminum facades, which acts as solar reflectors and thermal buffer. Aluminum in automotive sector is replacing steel due to lightweight, reducing carbon footprint and improving fuel saving. The use of 1 kg of aluminum could save a net 20 kg of carbon dioxide over the life of vehicle. Consumption in Europe in almost all parts of passenger car like engine, chassis and suspension, brakes, wheels, interiors, while in India it is limited to piston, cylinder block, etc. From a share of 8% in 2018, CRU predicts electrical vehicles to account for 30% by 2030. Aluminium used in solar cells account for 85% of most photovoltaic components in form of frames and mounting structures. Aluminium is quick to cool down, which is an advantage in solar PV cells, since increase in temperature of PV cells reduces efficiency of electricity generation. Huge demand for PV panel in India, around 10 gigawatt per year by 2030. Components of solar cells modules are imported from China. Hence, to discourage imports and encourage local producer, Government of India has come with anti-dumping policy. Extensive use of aluminum alloys for vehicle manufacture in US, Europe, and Japan, other metros, passenger trains, and express trains. The lower life cycle costs, reduce weight, less wear and tear for aluminum coaches offsets higher initial investment when compared to carbon steel coaches. India's first aluminum body metro train went into operation in Titagarh, West Bengal in March 22. Lightweight enables it to carry more payload and ensures high-speed performance. Additive manufacturing is going to be game changer. Innovative technology is 3D printing technology, which is otherwise known as additive manufacturing technology, is well developed in advanced countries for high value, low value complex products. In India, it is catching up and will be widespread in 2 to 3 years. It is useful for small size components of aerospace and automotive sectors. It ensures energy saving 5 to 15%, is of low cost and demands less cycle time. The yield is higher as there are no sub-processes like melting, casting. Wide range of sustainable aluminum alloys can be made. Though low carbon aluminum is costly, from life cycle cost point of view, it is attractive due to lower emissions and energy saving potential. Aluminum is sustainable metal of future due to high strength to weight ratio, long life, and excellent corrosion resistance compared to steel. 3D printing process is customized and sustainable for use in aerospace and automotive components due to less cycle time, energy savings, and cost effectiveness, owing to higher yield compared to conventional processes. Finally, the recommendations for Indian smelter to go green. Indian smelters need to procure mix of solar, hydro, wind, green energy online through Indian Energy Exchange IEX platform or alternate green energy exchange sources at competitive price on long-term agreement basis. Adopt best practices to improve energy efficiency by making process improvements and adopting advanced technologies. reduce net carbon consumption to a level of 390 to 410 kg per ton of aluminium. Smelters can go for Aluminium Stewardship Initiative, ASI certification for aluminium products, which is an international standard for sustainable and responsible production. Already some primary producers have gone for this certification in India. Smelters can go for ISO 14067 2018 version standard for quantifying carbon footprints of products. Aluminium plant producers should plan investing for renewable energy generation on their own in small steps. But already all the major producers have made plans of investing in solar energy and other renewable energies, which should be continued. They should go for advanced technologies in future expansion like APXC 500K, RA 550 of UC Russia, anyway, 600 kiloampere cell in China, DX Ultra of Emeritus Global Aluminium for a best energy efficiency in the range 12,000 to 12,500 kilowatt hour per ton aluminium. By far, the best technology available, which is on pilot scale trial giving very good results, is the HALE Ultra technology of hydro aluminium. It has given consistent low energy consumption to the tune of 11.6 kilowatt hour per kg aluminium to 11.7 kilowatt hour per kg of aluminium. And they have a vision to achieve 10 kilowatt hour per kg aluminium in future. Natural gas can be used as substitute for HFO, LDO in cast house and carbon plant. Green hydrogen as a fuel may be explored for auxiliary purposes in smelter. Digitization of smelter will optimize process efficiency and supply chain efficiency. Some of the producers have already gone for implementing digital transformation in their smelter. It involves digital technologies like digital twin technology, then artificial intelligence, machine learning enabled models, advanced analytics to optimize production, raw material consumption, and energy consumption. These smelters should focus on R&D work for developing sustainable aluminum alloys for specific applications, mainly in automotives, building and construction, aerospace, and consumer durables. I would like to acknowledge the help and support from friends internationally and nationally. Thank you for your kind attention.
Now, it's open for questions and answer. There are some questions already there in the messages. And Mr. Das, please see these questions. There is a question
How
from
do I
Yeah.
go to the question? Where is
This is. I will read the questions better. Mr. Sanjeev Kumar Dev, he's asking, in presentation, some places shown 4 kg per ton of aluminium and some places 4 ton per ton of AL. Which one is accurate? Which one is correct?
4 ton carbon dioxide equivalent per ton aluminum? Another is
4 kg. At some places you have written
No.
4 kg.
no. It is there was some problem with the software. I had yes, it remained. It is 4 ton carbon dioxide equivalent per ton aluminum.
Okay. And there is a question from Mr. Lipak Sahu. Which are the materials that are being used for making inert anodes?
As you
Any
know,
idea?
it is in pilot scale stage. What published literature says is it is a metallic anodes and cermets, a combination of oxides of metal and ceramics. That is what published of nickel and other materials, nickel oxide and.
Next question is by Mr. Srikant Kulkarni. Can hydrogen be used as reducing agent for aluminium smelting?
Hydrogen as a reducing agent, no, there has been no report as yet. It has been used in alumina plant for substituting gaseous fuel in as reported by Rio Tinto. And in electrolysis or in there has been no trial in there has been no trial published literature yet.
Mr. Lipak Sahu is asking, is there any initiative in NALCO for producing green low carbon aluminium?
You see, I have retired from 2013 July. Whatever is available in public domain, that's all I know. But I don't think there is any development for low carbon aluminium. But the efforts they have gone down the emission level in smelter overall. The emission levels has come down to a great extent.
Okay. What is the best footprint per ton of aluminium produced? Sanjeev Kumar Dev.
The best footprint is by Hydro Norway. Recently in Luxembourg, they have said it is as low as 0.41 to 0.3 ton carbon dioxide equivalent per ton of aluminium. And inert anode, if it is getting commercialized, it will be almost only due to alumina operation. There will be some carbon dioxide emission.
Mr. Pradeep Chaudhary, a very good presentation. Thanks, Mr. Das. And IBAAS additionally suggested the aluminium smelter should get validation for GHG emissions as per ISO 14065-2020 standard for monitoring and control and reduction of emissions as a step forward towards green aluminium. Okay.
Yeah, I agree with his statement.
Okay.
That is here to reduce, that is the standard to reduce greenhouse gas emission.
Mark Dupuis is there. India should investigate electro-swing capture technology from MIT.
Yeah.
Do you know anything about that?
Yes.
So
I have the information. I have the information. It is the latest development in recently held global summit, Green Summit. Hydro Norway has been successful in Smelter to reduce the emission levels, which is a technology of Massachusetts Institute of Technology, USA.
So by the way, okay, Mr. Das. By the way, Dr. Mark Dupuis will be presenting the next presentation in IBAAS lecture series, and that will be held in the June. Yeah, so we will announce that one, and Mark Dupuis is welcome to hold the this next lecture. Then John Clark, many thanks for the presentation. Kumar Sen, then Deepak, thanks. Sanjeev Kaur, sir, what is the best trend of power if 1 ton of aluminium? Produce wonderful presentation and initiative by IBAAS. Okay, these are just comments. So please, it's open for questions. Anybody wants to ask question directly, they can ask question. No, it's okay. That's not right. Can you look into it and your opinion?
Hello.
Yeah, please.
Yeah, this is Srikant Kulkarni. Yeah.
Yeah. Okay.
I have got a patent for the use of hydrogen or as a reducing agent for aluminium smelting.
Okay.
By reduction of aluminium chloride. So can Mr. Das just have a look at it and give his opinion?
Okay. Mark Dupuis, please let us know your query. Mark Dupuis?
Yes.
Please ask your questions.
Well, I was asking about Al0. That is the process that hydro aluminium is developing. That is another way to produce aluminium with zero emission. I think Das is aware about it. I have not talked about it in this presentation.
Mr. Das.
Yeah, I just replied to it. That is this is the recent development by Hydro Norway, and this technology is something like a reduction of alumina converted to aluminium chloride, and it also produces carbon dioxide, and this aluminium chloride can be electrolyzed to aluminium. This is the only development I know.
Okay, Mark Dupuis, you can explain this technology in your next presentation.
No, I'm not planning to present that. My presentation is on modeling, but I can complement. Al0 is converting alumina to aluminum chloride, and
Okay.
then making the electrolysis of aluminum chloride that produce CO2, but that CO2 is recycled,
Okay.
and the chlorine gas is recycled. So net, there is no CO2 production.
Okay. Interesting. This is interesting. Anybody wants to ask question to Mark or Satyanarayan Das?
Yeah, my question for Mark was that, Mr. Mark, I had developed a process for which I was granted a patent by IP India, that if aluminum chloride is reacted with hydrogen to produce aluminum metal and hydrochloric acid, and the hydrochloric acid is then neutralized by using dry ammonia, so that the reaction does not become reversible. Do you think this can be tried on pilot plant scale?
Well, if you have a process that can be tried, you have to find a partner, industrial partner, like in India or elsewhere, to produce a pilot plant. That's the way that like hydro aluminium, they have not invented that process that they call half zero. They have recycled an idea from Alcoa. They are trying again. And so if there's any process, you need to find a partner, industrial partner.
Thank you, sir. And it is because the electrolysis of aluminum chloride poses several problems due to the sublimable or the volatile nature of aluminum chloride. And in this process, the advantage of the volatile nature of aluminum chloride is taken, and aluminum chloride and hydrogen and dry ammonia are reacted together, and in the medium of molten aluminum itself. So I would share it with you, Mr. Mark, on your mail ID.
Can I make a
Thank you.
comment, Dr. Nandi, to this?
Yeah, Mr. Satpathy, Dr. Satpathy.
Yeah, this is Dr.
Yeah,
Satpathy.
welcome. Welcome.
Hi, Mark. How are you? Good to see you. Okay. So, Mr. Kulkarni, what you were telling, this is basically, I mean, chemistry-wise, it is possible to reduce by hydrogen. Now, hydrogen, people are doing very wonderful things. The problem in hydrogen is, handling hydrogen throughout the process. You can reduce it, but then how do you handle hydrogen right from storing, reacting? Hydrogen is very, very explosive. So that's the challenge which people need to work. Reducing agent, hydrogen is known as a very good reducing agent. It can reduce. How to transport it, how to store it, how to flow it, and then the total management of hydrogen, that is the real challenge. That's what I want to throw into the audience, so that the focus should be on that.
Yeah, and hence I had proposed that hydrogen is not to be purchased, but it is to be produced in plant, and directly nascent hydrogen is to be used.
So that's the thing, whether you produce hydrogen, when you produce hydrogen right from production till you use it, it all is very explosive, so that's the challenge.
Yeah.
Sir, I would like to add, I'm Sanjay here from Unimark. What I had learned and heard about explosive, everybody has told very correctly about it. I think the best method would be the water electrolysis, use of hydrogen in the process that minimize the explosion and other reasons. And balanced hydrogen could be used for generating the power and all, if team agrees to that. This sort of
and also the hydrogen can be used for producing ammonia, which is another reagent used in the process.
Hydrogen has to be always produced from water only, finally. That is the call.
Yeah.
The only thing is that once you produce hydrogen, the next step forward, how do you take it forward to use it? So they are all is the I would say the disconnect end needs to be connected so that
Yeah.
you get a total package of hydrogen reduction for any such a process, because smelter is just not like any other reduction where you can you need to have a very consistent uh, flow of energy into this to have the product, I mean, whether it is efficiency or whatever you call it.
Okay, Dr. Satpathy, do you think it is worth looking into?
Say, yeah, when many people are working on this, like you are working, it's a very good initiative. But only thing what I said is, you have to have a prototype development and go for its reduction. That's very expensive again. So you need to
Yeah.
look into industry who needs to support you your initiative
Yeah.
to take it forward.
Yeah, that is what I have been trying to get some support from aluminum industry in India.
Yeah.
Okay.
Thank you.
There is a question by Mr. Musty. I think any carbon footprint norms or global standard specifically for alumina refinery per ton of alumina production. Anything, Mr. Das, you can tell about this?
What is that? Oh, alumina plant.
Alumina, yeah.
Yeah, I have only focused on
On the smelter
smelting,
side.
and it as I said, people are mainly working on reducing the emissions from primary aluminium industry across the aluminium value chain, from bauxite mining till the end use products. Also, people have worked, but separately I don't know. That I have presented in my presentation. With Hydro Norway,
Okay, Mr. Das.
Elysis, all have worked, but separately I don't know.
Okay,
Overall,
okay.
across the aluminium value chain also, and the footprint, that is 4 ton carbon dioxide equivalent per ton aluminium, is covering only direct and indirect emissions. That is in the aluminium production in smelter and the emissions generated in power plant. And across the value chain, already in my presentation, many producers under different brand names. Hydro is very
Okay, Mr.
promising.
Das.
Hydro's
Okay,
progress
Mr.
is very
Sir,
across the aluminium.
That's sir.
Okay, we can ask Mr. George Benevolgi. George is alumina expert and he can tell about the alumina side.
That's sir. There is a last question.
George?
I'm terribly sorry. I cannot give you such a figure for you right now. I don't think that such a carbon footprint has been developed, or sorry to say, I have not seen such. But I'm not a real expert of this aspect. Thank you.
Okay, no problem. No problem. Okay, any more questions?
Sir, Nandi sir, there was a last question during my appreciation note. I was looking for the best trend of the power if 1 ton of aluminum produced. Why I'm saying lower is the power consumption and the best technology used by any of the world producer that can give the productivity and the best prices of the aluminum cost versus the bauxite till conversion till final aluminum. So what is the best trend? I just wanted to know with the knowledge of Mr. Das's this thing of so much year of working.
Yeah, I respond. As far as I know, it is 390 kg per ton of aluminum.
I
Carbon
didn't get
content.
you, sir. No, not the carbon, sir. I'm asking the power. What is the power? Say people say
Power.
power,
Power,
sir.
I have already said in my presentation, the lowest is 12,300 reported by APXC.
Okay.
But the design stipulates 12,000 kilowatt hour per ton of aluminum, and hydro ultra XC, ultra 4, HL4E ultra, which is in pilot trial, very advanced for last 12 years or so. That gives consistently 11,600 to 11,700 kilowatt of ton.
Absolutely,
aluminum.
absolutely. That's what the bottom line.
And there is vision to go down to 10,000 kilowatt hour.
Yeah. You said 10,000 kilowatt hour. So I think once this power consumption goes down with the value chain of aluminum as well as the carbon footprint, and automatically the production and the sale of aluminum becomes viable, more and more, efficient, and
Yeah.
that will come into the world.
Okay, any more question? Mr. Vibhu Mishra, would you like to comment? Mr. Vibhu Mishra? Hello? Any more questions?
I think a great presentation. Okay, congratulations, Mr. Das. Very nice presentation.
Thank you, sir.
Mr. Das, very nicely elaborated presentation. Thank you so much, sir. Sanjay from Unimark.
Thank you.
Thanks to everybody. And we will be having a next lecture series by Mark Dupis, and he will be presenting paper, and that will be announced shortly by IBAAS office. Thank you to everybody, and see you in the next lecture series. Bye.
Thank you.
Bye.
Thank you.
Bye.
Bye.
Thank you, Mr. Mark, for joining.
Yeah,
Thank you
bye.
very much. Thank you. Bye.
Bye. These questions answer, you take everything. Okay. Mr. Das?
Yes, sir.
You have to revise your presentation, because some place it is 4 kg, some place it is 4 ton. So please revise your presentation and send to us.
Maybe in one place. Yeah. Tomorrow there was a software problem somewhere. Okay, I will do it.
Okay.
And send it.
Okay.
Thank you for giving me an opportunity to share my presentation.
Okay. Bye. See you.
I was help a lot. Yourself, Priyanka.
Thanks. Welcome.
Because I was very new to video recording and all that. I didn't have a proper.
Okay, no problem. We can discuss separately. Okay, bye.